Bismillahirrahmanirrahim. Assalamu alaikum. I am Taiba Fatma. How are you girls? Hope you are fine and doing good. Today we have revised some definitions, formulas and methods of measures of dispersion. These are very important and you can go through with me. Dispersion. Dispersion refers to the variation of the items among themselves around an average. Greater the variation amongst different items of a series, the more will be the dispersion. There are two types of dispersion, absolute dispersion and relative dispersion. Expressed in the same units in which data is expressed is called absolute dispersion. For example, rupees, kgs, liter, kilometers, etc. are the units of absolute dispersion, and in relative dispersion in the form of ratios or percentage, so it is independent of units. It is also called coefficient of dispersion. There are different methods of measuring dispersion: range, interquartile range and quartile deviation, mean deviation, standard deviation, and coefficient of variation. Range. The range is defined as the difference between the largest scores in the set of data and the smallest score in the set of data. We find out the difference between the largest value and the smallest value. In this example, largest value is 9 and smallest value is 1. So XL minus XS, L for large and S for the small. 9 minus 1 is equals to 8. So 8 is your answer. Interquartile range and quartile deviation. Interquartile range is the difference between the upper quartile and the lower quartile. It covers dispersion of middle 50% of the items of the series. Symbolically, interquartile range is equals to Q3 minus Q1, and quartile deviation is half of the interquartile range. It is also called semi-interquartile range. Symbolically, quartile deviation is Q3 minus Q1 over 2. Coefficient of quartile deviation, it is relative measures of quartile deviation, Q3 minus Q1 over Q3 plus Q1. This is the formula of coefficient of quartile deviation. The semi-interquartile range, we already revise it. Semi-interquartile range is Q3 minus Q1 over 2, and first quartile is equal to the 25th percentile and third quartile is equivalent to the 75th percentile. Mean deviation. It is also called average deviation. It is defined as the arithmetic average of the deviation of the various items of series computed from measures of central tendency to the mean or median. According to the formula or according to the question, if we find out from mean deviation from median, the formula is summation absolutes x minus median over n, or mean deviation from mean x summation absolutes bars x minus x bar absolute bar close over n. This is a formula of ungrouped data. Or it is also called mean deviation from shortcut method. This is the same formula. Next. Standard deviation, most important and widely used measures of dispersion. Also called root mean square deviation. It is defined as the square root of the arithmetic mean of the squares of the deviation of the values taken from the mean, denoted by sigma. Sigma is equals to under root summation x minus x bar whole square over n, or summation x square over n, where x is equals to x minus x bar. Coefficient of standard deviation is equals to sigma over x bar. Calculation of standard deviation. There are three types of standard deviation: individual series, discrete series, continuous series. Standard deviation individual series, it is actually a ungrouped data formula we are using in your book. It is using a ungrouped data. Sigma is equals to under root summation x minus x bar over n, the x minus x bar whole square over n, or summation x square over n, where x is equals to x minus x bar. Standard deviation discrete series, actual mean method, also we also, or it is also called group data method. Here frequency is given to you, sigma is equals to under root summation f x minus x bar whole square over n, and where x is equals to x minus x bar, so we put it under root summation fx square over n. Coefficient of variation, it was developed by the Carl Pearson. It is an important relative measure of dispersion. It is used in comparing the variability, homogeneity, stability, uniformity, and consistency of two or more series. Higher the coefficient of variation, lesser the consistency. Coefficient of variation is equals to sigma over x bar multiplied by 100. Sigma stands for the standard deviation over mean multiplied by 100. So thank you so much. Please revise this formula, and through these formulas you can solve your exercise questions and examples also, which are given in your book. Thank you.